Hello, everyone. I'm Diego Fanesi, Lead Specialist Solutions Architect for Databricks. And today I have here with me Karol Zemko from Česká, Erste Group. Today in this session, we are going to talk about AI readiness and how consolidation to a single data platform is key for reaching AI readiness. Before we start, I wanted to do a little intro. We see here, probably you have seen those pictures numerous times. We have here Gartner quadrants and also the Forrester Wave in 3 different areas of the big data kind of landscape. Data science and machine learning, the database cloud solutions, and the data lakehouses. This represents kind of the perception of the market of the Databricks platform. It can clearly show that our customers believe that Databricks is providing market leader performances on all those areas of use cases. And this is key because when you're looking to unifying to a single platform, you really don't want to migrate to a platform where there will be compromises or a lot of compromises on the TCO aspect and on other aspects. So Česká is part of Erste Group. Erste Group is one of our strategic customers in the financial sector. And Česká is their biggest division. So 2 years ago, Česká was unifying on Snowflake, so migrating all their data platforms on Snowflake. Well, today they selected Databricks as their main strategic data platform, and they are now migrating all their use cases, all their data platforms to Databricks. So Karol's team actually deployed the first workspace into Erste Group 3 years ago. And now, today, Karol is leading the data platforms engineering team at Česká, and he's responsible of all the cloud data platforms. So we are going to hear from him why they made this choice, what were their evaluations, and how they ended up into making this decision. Please welcome Karol Zemko.
Thank you very much. So let me give you a bit of a context about Česká Spořitelna, so you know what we're dealing with. Česká Spořitelna is the biggest bank in the Czech Republic. We serve individuals, SMEs, municipalities, other state entities, and also large corporations. And we also provide additional financial market services. And as was previously mentioned, we are part of Erste Group, which is one of the leading banking groups in Central and Eastern Europe. And this is really to showcase that we as a banking entity have quite a lot of data, and at the same time, we have a varied, let's say, portfolio of workloads we do. This includes collaborative projects across the group. So, about our journey. 7 years ago, we adopted Databricks as a tool, mainly to really help us with classifying our customers. And this was in the form of models, propensity to buy models. So we are talking about classical machine learning, predating AI. And at the time, it was very useful for this, but it didn't saw broader adoption in the bank. Then 4 years ago, business has showed keen interest in Databricks, and they started using it not just for classical models, but also preparing data for marketing journeys to Salesforce. And Here again, Databricks proves itself as a platform not just for machine learning and data science, but also to do data engineering. Then, 3 years ago, as was previously mentioned, after some showcases to the rest of the Erste Group, a POC was organized where we deployed the first Databricks workspace through our deployment standardized pipelines in the Erste tenant. And this was really for Erste to try it out a bit themselves. Then, 1 year ago, we productionalized our first AI use case. The use case was for preparing personalized tips about clients for banking advisors. And from then, many followed. And now we are getting to the more interesting part. 10 months ago, Erste adopts Databricks as the group-wide platform solution. Afterwards, 6 months ago, Česká Spořitelna adopts it as its main data platform. This was from, let's say, the previous Snowflake. From this, you can see a clear trend of acceleration. Now, where are we today? So we are standardizing our entire stacks. This includes not only, let's say, migration, but also integrating our existing in-house tooling and processes into the platform. We are also migrating, basically everything we have, Cloudera, Snowflake, SAS, and other platforms, and either in part or fully. And we are doing more and more collaborative projects across the group. And all this is to achieve this idea of a unified platform and a unified data strategy. And basically all this context was to really ask the question, why did we decide to do this pivot? And what were the different reasons for the accelerated adoption? So maybe let's start by looking at some of the challenges of having such a large technical stack. First of all, data is fragmented. You have operating data quality, governance model, and you cannot really maintain a standard across all your stack. This is especially relevant since we have a strategy of AI-first adoption, and the creation of a unified AI semantic layer is either very difficult or basically impossible. Next, having platforms with equivalent capabilities drives IT cost. You obviously pay extra on maintenance since you need to have multiple qualified personnel to maintain the platforms, but even more so, oftentimes, they do it independently of one another. So this really drives basically just maintaining the existence of having them around. And you have the licenses on top. So if you deal with licenses, obviously you have the cost, but there is also another aspect of added complexity where, don't get me wrong, a license model can work, but optimal results are only if you precisely estimate your needs for a specific time period. So this ideally doesn't fluctuate in the next year. And if you need to buy hardware because you are running on-premise solutions, this is just a cherry on top. So this can really throttle growth. Then, another issue that we have is complication with group-wide collaboration between multiple entities, because we didn't have a unified stack. Obviously, this doesn't need necessarily to be your problem, but on a, let's say, just company level, this also limits sharing of information and knowledge, because everybody is working with a different stack. And the last hurdle that we needed to overcome, basically with having such a wide portfolio, is imposing some sort of standardized AI governance. Now, this is very difficult in the best cases to have across the platform, but you have the added complexity of having both cloud platforms and on-premise platforms. And for European companies, this is especially, I would say, tricky, since besides the local regulations and compliances that you need to follow, there is also the overarching one of the EU European EU Act on top of it. So, all this, what I said, was some, let's say, challenges from having a large stack. Okay, but let's look at what basically pushed us into this migration, into this pivot, and do it so quickly as we are doing it around. So we did quite a few migration viability assessments for different platforms. And across all of them, we basically find some similar information. The first one, it will probably not be a surprise, but they can be quite costly and time intensive, especially if you are doing multiple of them at the same time. So this is the obvious. But beside it, we find that lift and shift methodology of simply moving code bases from one platform to another doesn't really work as well as you would expect. And it's more beneficial to put in the effort and to refactor the code. So why is this? Well, first of all, you are basically, if you are migrating in the lift and shift method, you are paying resources to translate your technical debt into a new platform. This is extra poignant if you are, let's say, have a 20-year-old Oracle DWH on-prem. Other aspect of this is, well, if you are just lifting the code and putting it into a new platform, you wrote the code in the original place, and it's not surprised that it's probably running best there. So you are effectively not utilizing the new paradigms and the new shifts and tools that you have at your disposal if you are just lift and shifting it. So all of this basically defeats the purpose somewhat of migrating. Also, there is no better time to basically future-proofing than when you are migrating. And what we found is that really the previous tools, such as the Lakebridge, without the AI integration, wasn't working very well for us. You would really, even with simple Databricks assistant, we had much better results. So now with tools such as a Lakebridge being integrated with Genie Code, this really opens the possibility of new adoption. Then there is the aspect of openness. You have Iceberg that basically makes the platform more open, but the most important thing is you don't have to migrate really the data from one data type to other. It's basically just a flag. There is native support, the performance also doesn't suffer. Other aspect is that the decoupled storage and data. So for example, with Snowflake or with Fabric, you have this aspect that you need the compute to access the data. Here it is in your native basically storage or S3 bucket. Then there is the aspect of integration and connectors where we have now with the expansion more connectors to use, and at the same time we also can integrate our in-house built tools into Databricks. And now with, as was said in the keynote, open sharing is another thing that will be expanding this integration capability. Another thing why we are basically bullish on Databricks right now is that we, as a banking entity, need to also handle regulatory workloads. Be it to the Czech National Bank or be it to the rest of our Erste Group as a parent entity. And not to oversimplify, but with these types of workloads, costs are not really your primary interest. There are things such as stability, reliability, auditing, and security which take precedence in this. Based on our initial analysis, newly implemented features such as disaster recovery, failover across regions, exclusive groups, all this really opens the door to now be able to do these kinds of workloads in Databricks. So in detail. Disaster recovery with failover to other regions means you have a better stability, the workloads will not fail, you are able to basically continue. Exclusive access for groups, that's another very interesting feature that we are quite extensively testing right now. If you are not aware of this, it basically changes the governance model from a cumulative one, when all your accesses are basically added together, to an exclusive where you switch to this group and you only retain the privileges that you have. And we are using this to basically create a form of enforcement of data contracts on the platform level. Other things which are quite specific for us, but we need, for example, hardware security module encryption, which we are able to do on Databricks, not always possible on other platforms. And last but not least, some sort of verbose auditing where we can really track every action that is being done. And with all these tools, we are basically investing Q3 and Q4 to really tackle this, not just from the platform level, but also from the operational level of our bank, to be able to basically migrate the entirety of Oracle and those regulatory workloads into Databricks. So, final thoughts for my part. These were all the reasons that we currently are investing in this strategy and pivoting from Snowflake. But maybe something that you noticed is I didn't really talk about performance much, or basically not at all. And the reason for this is because Diego Fanesi did an excellent analysis on our behalf, and I would like to basically let him tell it about himself. Well, thank you very much.
So essentially we have some few open questions still, right? Can Databricks perform on SQL use cases, right? Is the SQL performance on Databricks at the same level as other platforms? And how Databricks and Snowflake perform on open data formats, and how TCO is impacted when we bring in something like Iceberg or other open data formats. This is very important because sometimes companies and customers will consider architectures, they will not really test it, they will not really thoroughly evaluate it from all the aspects, especially from the query performance and the TCO aspect. Then they start migrating into it, and then they find that it's not feasible for them. So when we talk about performance and TCO evaluation, this is not an easy topic. Many customers will go through POCs, but getting also the POC right is not trivial. The focus, here are some best practices that I've learned across customers and across POCs. So you should rather focus on the biggest consumption drivers. So biggest data sets, biggest queries, long-running jobs, because you don't want to spend your time into those queries that are going to save a few cents of a dollar, and then actually have something that is lower on the biggest query that are going to compose 60, 70, 80% of your overall consumption. Another aspect is that you are not executing this exercise as a data engineering team, well, not data engineering team, but as an engineering team of a product, but rather you should do this exercise in a way that really reflects your point of view, which is cost. You want to see the end cost and evaluate the end cost of your platform, of your architecture. So for that reason, you should do a comparison that is on idle cost parity. So that means you don't look at instances that are being provided or other aspects or cores or stuff like that. When we are looking at serverless offerings, those are technical details that doesn't really make a difference for you. What it really matters is cost at idle time, okay? Cost at idle time, because the warehouse is not going to be fully utilized at every second. You're going to have large utilizations, and that's where query cost is important. And the second aspect is when you don't have a full utilization of the warehouse, that's where idle cost also becomes important. If more use cases are part of the same POCs, always sum them up all together and compare the total overall TCO, not use case by use case. Why? Because you want to see really what is the platform that is overall able to give you the highest level of savings. When we look at benchmarks like TPCDS, you probably are familiar with this. We publish that on data sets of 10 terabytes, 20 terabytes, 30 terabytes, you can save 20%, 26%, and 41% on costs between Snowflake and Databricks. However, this test is only the sequential query test. Doesn't really bring concurrency into the picture. And the second objection that we get from customers when we show this is, well, 10 terabytes data set. My data sets are hardly that large. Well, let's see if this is true. So on the right-hand side, you can see the structure of the test, TPCDS. And on the left-hand side, you can see the sides of the tables. So first of all, we are talking about 10 terabytes split over 24 tables. Second, 10 terabytes is the raw data, so it's uncompressed CSV format. After ingestion is much smaller. We are talking about 3 terabytes. This is not because we filter data, but because Delta tables, but all the also other formats, also Iceberg, is particularly efficient in compressing data because there is no filter data. So the results we have seen in the previous slides are really executed on a data set that looks like this. And look, there is only one table that is above 1 terabyte size. And we have 3 fact tables, and then we have a long tail of very small tables. Why? Because this is clearly star schema. So we have dimension tables and fact tables. I'm sure that if you now go and look at your workspaces, you will be able to find more than one data set that is either bigger or at least of the same size of this. However, there are some challenges, especially when we look at TPCDS implementations across all vendors. And those are, most implementations of TPCDS only focus on sequential query execution. So it doesn't really bring concurrency into the picture. And if we look at other implementation, most implementations only use the data generator and the queries, but disregard most of the specs of TPCDS, because TPCDS is a third-party industry standard benchmark that is very strict and very rigid, okay? Some vendors will go to the extent of using pre-ingested data set. They went through and fully optimized those at a level that is probably not feasible for production use cases. Well, nobody knows, right? And in some cases, they will also use proprietary tools, which, the transparency of all of this is not really, it's not easy to gain transparency over what they have done and how they obtain those numbers. And ETL and concurrency often remain uncovered. So this was the motivating factor for me to start my work and redevelop the TPCDS starting from the official specifications. I did it with JMeter. Why? Because JMeter is open source tool that many, that generally in the market is used to benchmark. I metered ingestion and concurrency tests, not only power tests. Today we are going to see just ingestion and concurrency for time reasons. And I tested it on multiple data sets, so 100 gigabytes, 1 terabyte, 10 terabytes, and I tested it on Iceberg, Delta, and native tables on Snowflake. I compared at idle cost parity. Of course, there is never a perfect correspondence between Databricks and Snowflake, but they go very close when we are on the same sides. And then I fixed the number of clusters to 1 on both platforms. Why? Because I truly want to see how concurrency is going to push to the limit that single cluster to the point where we are forced to scale and add more infrastructure. The tiers I consider is Databricks Enterprise and Snowflake Enterprise. So those are the results for the ingestion costs. And I was able to measure 66% lower cost on ETL for the 1 terabyte scale, 78% cost on the 10 terabyte scale, and we still have some savings on the smallest data sets, which is about 10%, and of course, those are just 30 cents, okay? Because the full test was about like a few dollars. So of course, the savings in this case is very little. And that's the reason why you should focus on what is going to drive most of the cost in your platform, so the biggest data set and the biggest sizes. This is the results of concurrency tests. So we are talking about 20 parallel query streams. The order of the query is also decided by the specifications. I follow the same order. And this is Databricks Delta using liquid clustering versus Snowflake native tables using their clustering functionality. And 25% cost savings on BI and analytics for 1 terabyte, 29% savings on BI and analytics for the 10 terabyte scale, and 2.4% cost savings on the smallest one, the 100 gigabytes. Again, we are talking about a few dollars, so it's just 10 cents, right? Which is pretty much the same thing we have seen in ingestion. Now, what happens when we bring Iceberg into this picture? Well, one thing to notice is that we already achieved open data format on Databricks, while we did not achieve this on Snowflake, right? But if we truly want to standardize on Iceberg, how does TCO and query performance change on both platforms? So in this overview, this is just Snowflake. So it's Snowflake versus Snowflake. Snowflake managed Iceberg, Gen 1 and Gen 2, and Snowflake native tables, Gen 1 and Gen 2. And you notice how already you have an increase in price, right? The TCO is 15 to 26% higher, 5 to 19% higher for the 1 terabyte, and 23 to 27% higher for 100 gigabytes. Now, there is one aspect. So the two percentages, one is Gen 1 to Gen 1, the second percentage is Gen 2 to Gen 2 comparison. There is no price difference on Snowflake, whether you are querying an Iceberg or a Snowflake native table. So all this difference is coming from lower query performance. This means you're paying more to get less, to effectively degrade the experience of your users. What happens if we look at Databricks, right? Delta versus Iceberg. Well, the savings, you can see it for yourself, from 21, 38 to 45% savings. But the most important part is that Delta versus Iceberg is 0% difference across all data sets. This is very important because as Databricks, you have seen it this morning in the keynotes, we are effectively publishing, releasing new features in the context of Iceberg, but we really don't care if you want to use Iceberg or Delta. Our implementation of Iceberg also has liquid clustering in our platform that is not available on the other platforms. And this is also one of the main reasons why the costs on our platform are so low. This is a little bit about the query performance of concurrency tests. So this is percentages. You notice how essentially Databricks on Iceberg is able to outperform even Snowflake native tables on Gen 2 on pretty much all the sizes I tested. So to me, this is what means for a platform to be open, right? A platform to be truly open, it means there is no performance or TCO gap, not even feature gap, between their own proprietary format, if any, in this case Databricks doesn't have it, and an open source data format, right? If you're not able to show this, you are not truly open because customers will start implementing on top of Iceberg, and then they will be forced to migrate back to native tables because of costing reasons, because users need faster queries, or simply because there are feature gaps between the two formats. What about adaptive? So Snowflake has this new warehouse type, which is called adaptive, and it essentially means autoscaling. So autoscaling is effectively built to handle high concurrency use cases. So what happens if we start using adaptive, and why adaptive was not part of my results? Well, there is actually a good reason. I tested adaptive. I did 2 runs with adaptive. So first approach was, okay, it's auto-scaling, so I will just configure it to completely be uncapped, right? You can have as much hardware as you want. You figure out how much you need for those queries. And the tests ran very fast. But costs were to the roof. So apparently, the auto-scaling of adaptive over provisioned hardware pretty much all across the queries. And this resulted in quite a big waste. Then I decided, okay, then I will kind of cap the size to the same size I used for the other tests. And I will also reduce the throughput ratio to 4 and see how it behaves, right? And costs are much more reasonable, right? But still higher compared to all the other tests. So, this led me to think it's extremely hard to size it correctly. And, I felt it was almost unfair to include it into the results. So, to simplify, I decided to exclude it. So, don't trust me. Don't trust what I presented it. Tested it for yourself. I am open sourcing the code of my benchmark. You can take it. You can run it. By default, it's simply... What happened? Okay. It's simplified to run on a Databricks notebook, but you don't have to. You can even export the JMX files and the queries and run it on your laptop. And this may be useful also to test your own architectures, especially if you're implementing unified data layer. Those tests only covered managed Iceberg for Snowflake and managed Iceberg for Databricks. When you are using external tables on Iceberg on both platforms, things can change, right? So key takeaways. So we saw how consolidating to a single platform is a key aspect to reach AI readiness. This is because, especially for the financial sector, you want a unified governance layer across all your assets, across ML, AI, functions, data, federated sources, and so on. That will also give you a full coverage in audit logs, who has accessed what, and so on. So also when we talk about AI readiness, not all your AI applications are going to run inside Databricks or your data platform that you chose. So open data formats also become important. The ability to access your data from another platform also become very important. And you don't want that this choice of open data formats will bring any compromises in terms of query performance, in terms of TCO, and so on. So that was it for me. If you have any questions, I will be around for quite some more time. And yeah, happy to answer it later. Thank you.